So today we are going to deal with the topic of potential energy of a dipole. And those who have been paying attention, even yesterday also looking at some questions, we got a hint why a dipole should have potential energy. Okay, and we looked at that kind of a ring placed in vertical plane, and it will start rotating. It will acquire rotational kinetic energy, and rotational kinetic energy does come from potential energy. And second thing we try to relate to the torque is very similar to torque experienced by electric dipole. Yes, if the torque is similar, work done by torque also will be similar. The expression is identical to what we have done earlier. So it is not a surprise. It is something which can easily you can anticipate. And let's quickly look at what is the expression we get. Potential energy of a dipole placed in a field. What is the torque experienced by the dipole? Torque experienced in terms of magnitude is m cross b. And why I have put a minus sign here? If we take a theta as the direction of angle, the dipole makes with the magnetic field. The torque is opposite to angle theta. So this minus indicates that it is opposite to angular position of magnetic dipole with respect to magnetic field. And what is change in potential energy? Change in potential energy, basic definition always remains same. Change in potential energy only associated with work done by conservative force. Even magnetic force is also a conservative force. And in case of translation, it is F dot dr. In case of rotation, it gives you rotational kinetic energy. And there we write change in potential energy equal to, again, negative of work done by the torque. It will be minus tau by d theta. Tau indicates torque due to conservative force here. So this is torque value. What is the torque? Torque itself is negative. When we substitute value of torque here, this negative will get positive. So this is the change in potential energy corresponding to small change in angle between m vector and b vector. But if the angle changes from some initial angle theta 1 to theta f, initial angle to final angle position theta f, in that case we need to integrate from initial angle to final angle. And when we substitute minus has become plus, we have substituted value of this term in this equation. It becomes mb sine theta d theta. It's extremely simple integration. So it becomes minus cos theta. If we take minus sine outside, it is minus mb cos theta f minus cos theta I. This final angle, initial angle. This gives you change in potential energy. To define potential energy, we need to choose a reference. And if we choose reference, if we take potential to be 0 when theta is equal to pi by 2. So initial angle we take at theta is equal to pi by 2. So if we take this angle as pi by 2, this term becomes 0. It becomes only cos function. It becomes like a dot product. That's why we take potential to be 0 at theta is equal to pi by 2. So when they are mutually perpendicular, we choose the potential energy to be 0. When which two are mutually perpendicular? A vector and b vector. So in terms of that, so potential energy is equal to, using this as a reference, we can define potential energy is minus m bar dot b bar. It's a dot product of two vectors involved. And we can also write that is equal to minus mb cos theta. Okay, that's something I have not written. Is in terms of magnitude, this is equal to minus mb cos theta. So if you want to understand how this potential energy changes, potential energy follows negative cos theta curve. Cos theta, if you draw negative cos theta minus cos theta curve, varies as negative cos function. And since cos decreases from 0 to 180, this will gradually increase from 0 to 180. Okay, so if you recall, what is the shape of cos theta curve? It will be minus cos theta curve. So if I have to mark this curve minus cos theta curve, and this angle is 0, this angle is 180, cos theta curve will do something like this. What you notice here, it will keep on increasing. When is the potential energy minimum? Potential energy is minimum, which is equal to minus mb when theta is equal to 0. It becomes 0 at theta equal to 90. It becomes equal to plus mb when theta becomes 180. And so any two angles, we can calculate what the change in potential energy is. And if we relate, and in fact, we had done previous case also, what you notice here, torque is equal to what? What is torque? Torque is equal to force into displacement. And potential energy is similar to work done, which also is force into displacement. So dimensionally, torque and potential energy have same dimensions, and we can compare these two quantities. So just to have an idea, but this is not nothing we need to make a table about, but still just to understand, when angle theta is 0, torque is equal to 0, mb sine theta, and potential energy is minus mb. And this is 0 equal to minus mb. When this angle becomes 30, torque becomes equal to mb cos 30, which is mb by 2. And potential energy in that particular case will be equal to minus of mb cos 30, which will equal to minus root 3 by 2 mb, and 60 degree, 90 degree. So what happens in case of potential energy? By the time we have to rotate it by 90 degree, from minus mb it has become 0, so on and so forth. Okay, so if we have to calculate what is the change in potential energy if dipole is rotated by 90 degree from initial position of equilibrium. This is a position of initial, this is a position of equilibrium. So here the torque is 0. This is a position of equilibrium. What is work done? Suppose I ask you, what is the work done to rotate by 60 degree? Or what is the work done to rotate by 60 degree? Work done by rotate by 30. See, it is something I can mark it here also. 30 degree, 60 degree. What is the work done to rotate by 60 degree? Work done to rotate by 60 degree will be increase in potential energy. This is the quantity of work done to rotate by 60 degree. And similarly, if I go for other cases also, work done to rotate by 90 degree, this will indicate work done to rotate by 90 degree. What will work done to rotate by 90 degree? Final potential energy minus initial potential energy, which will equal to mb. What is the work done to rotate by 180 degree from position of equilibrium? In that case, work done will be final potential energy minus initial potential energy. So always keep in mind, when I subtracting minus potential energy, this term is getting positive. So in that case, work done will be equal to mb. So this is something very easily, but this is not very complex thing. But this negative sign comes in, so we understand how to factor that. So we can calculate and we can find the ratio of torque and how the torque and potential energy at a particular angle are related, how work done are related. So this very simple application of two formulas. Torque is equal to what? Torque is equal to m cross b, and this is simple use. Very similar to what we have done in case of electric dipole. And what is potential energy? Minus m dot. And in terms of magnitude, we can write. So this is all we need to know in case of potential energy of dipole. Rest all is a simple application of very basic things. So let's look at some very simple question. What is given here? This is, in this case, a current carrying loop is placed in a uniform magnetic field with 4 different orientations. So what we understand, the potential energy of a dipole placed in uniform magnetic field depends on its orientation, angle it makes with magnetic field vector. So 4 arrangements are shown. We have to arrange them in decreasing order of potential energy. And what we understand, as theta keeps increasing, P keeps decreasing. What does this mean? As theta keeps increasing, potential energy also keeps on increasing. Wherever theta is maximum, all we need to do, we need to identify theta, because potential energy is increasing, it's an increasing function. I hope you understand. It's continuously increasing function. As theta keeps increasing from 0 to 180, potential energy keeps on increasing. So in all case, we need to identify what is the angle here. In this particular case, if this is a vector or this is the direction of m bar vector, the angle between them is 180. The angle is 90. It is acute angle, and here it is obtuse angle. So each particular case, it has a particular potential energy, and smaller the angle is, lower the potential energy is. Which case this angle is smallest? This is the smallest angle, and this will have the least potential energy, and this is the largest angle, it will have the maximum potential energy. So what is the order? Least, that's the next higher angle, acute angle, right angle, obtuse angle, 180 degree. That's the order of increasing. If you have to arrange in decreasing, other way around. I hope all are clear how to calculate. This is pretty simple question. I hope all of you understood what it is. What is the order? If you have to arrange the decreasing order, of the first one is the largest, and which is the small in angle, smaller next angle. This was the next angle. After one, fourth one should come, and after that, the second one, and the least energy is the third one. Let's look at some more question on this. magnetic needle. What is a magnetic needle? I think this is something we will come to this point again later. Magnetic needle is nothing but a dipole. So when we talk of magnetic needle, think of a dipole. And what is the direction of a magnet? What is a dipole vector? It's a vector quantity. So if I have a magnetic needle, and those who have seen, I think all of you must have seen magnetic needle. In many cases, magnetic needle, one end is colored in some other form. So this indicates north side. So what is the direction? The magnetic needle is a dipole. What is the direction of dipole vector in case of magnetic needle? The direction is from south to north. This is the direction of vector. It is lying in parallel to magnetic field. So initially what is given, it is equivalent to saying a magnetic dipole is lying in a magnetic field. If it is lying in magnetic field, what is given here? Theta is equal to 0. The initial angle is 0. It requires work of W units to turn it to 60 degree. First of all, can we calculate work done to rotate by 60 degree? What is work done to rotate? What are we rotating? Needle. Or if needle also, we can think of what? What is needle? It's a dipole by 60 degree. So if we visualize what are the initial state? Initial state, this is the B vector. And initially M vector also like this. Theta is equal to 0 degree initial. In case PE initial is equal to minus MB. If I rotate by 60 degree, what does rotation by 60 degree mean? B vector remains same. This M vector has been rotated. So this needle, I apply it. So if the needle is lying like this, if I apply force in this direction, if you apply a couple, if I with my hand also I can rotate, I turn it by 60 degree. So when I turn it, actually I'm applying a torque, I'm doing some work. And this angle theta becomes 60 degree. This is how the vector is. And you can think of a needle also. What is the final angle? Final angle is 60 degree. In case of potential energy is equal to minus mb cos 60 is equal to minus mb by 2. What is work done? Work done equal to, there is no change in kinetic energy. Work done is equal to final change in potential energy, final potential energy minus initial potential energy. What is final potential energy? Yes, Vignesh?
Sir, isn't it supposed to be initial potential energy minus final potential energy?
Which one?
Work done, like negative of the change in potential energy, right?
No. See, what are you saying? If you have two different ways, what is change in potential energy? We always say what is work done equal to? Work done equal to change in. This is work done by what? Not by conservative force. So when I'm rotating this needle, I'm applying force from here. How do I rotate this needle? I apply force like this. With my hand, with 2 fingers, I can twist it. Is the work done by conservative force or is it work done by external force?
Okay, this is work done by external force.
Work done by external agent, non-conservative. This is what it is.
Yes.
So it is like this. So let's write this term minus mb by 2 minus initial value, which is minus mb, and which comes equal to mb by 2. That's the work done, which is given as W. Now what we need to do, what is the torque needed to maintain the needle at this position? To visualize, if I turn this needle like this, needle will tend to come back in the same direction. What I need to do, I need to apply force like this. And so then only, so I'll need to apply a torque here. What is the torque I need to apply? This torque, external torque, has to be equal and opposite to torque experienced by the dipole. Then only it will be a state of equilibrium. So it has to be, external torque has to be equal and opposite. So in terms of magnitude, the external torque which need to be applied to keep in a state of equilibrium, magnitude has to be equal to M cross B, torque experienced by dipole. Then only it will remain in equilibrium. What is this term will be equal to? It will be equal to MB sine 60. This angle is 60 degree. And that will be equal to root 3 by 2 MB. Now from first one, I get MB value equal to 2W. So if I want my answer, what is the torque which need to be applied to hold this needle in equilibrium? I substitute the value of mb from the first equation, which is equal to 2w root 3 by 2 into 2w, that is equal to root 3w, is the thought which I need to apply. And I hope all of you understand. I can relate those two terms because they have the same dimension. Though they do not represent same physical quantity, but I can compare these two quantities because they have the same dimension. So that's the value of torque what I need to apply to maintain the needle in this position. If I extend this question, suppose I ask another question. What is the part B of the question? Part B I add. What is the question here? Work done to rotate by 60 degrees W. Now, if I extend the question, I ask you, what is the find additional work done? What is find additional work done to make needle perpendicular to magnetic field? What is the additional work I need to do in terms of W? Make needle perpendicular to B. I'm talking about additional work done. From where to where? Now I'm rotating from initial angle 60 to theta final is 90. So again, when I work done also, work done will be equal to final potential energy minus initial potential energy. What is the final potential energy corresponding to theta is equal to 90 minus mb cos 90, which is 0. Final potential energy is 0. What is the initial potential energy? This will be equal to minus mb, initial angle is 60, minus mb cos 60. So what is the work done? It will be equal to, again, mb by 2. What does this mean? Whatever work I have done to rotate it from 0 to 60 degree, the work done to rotate from 60 to 90 also again will be equal to W. So if I look at the previous slide also, what does it mean? Whatever work I have done to rotate from here, this started from 0, this is 60 degree, and this is 90 degree. This is the work done to rotate from 0 to 60 degree. And from 60 to 90 also, again, the work done will be, again, W. These are increase in potential energy from 0 to 60 is same as increase in potential energy from 60 to 90. Okay, so potential energy is fairly simple if you know the angle. So there are not too many complex questions. Let's look at some more questions which are based on thought and its application. And this is past IIT question. So take a minute, all of you read this question carefully, think how you're going to solve it, and then we'll discuss it. Okay, so let's try and understand what is being asked here. Charge q is released from the origin with velocity. Actually, released is not the word, it is projected. Which is velocity is given minus v naught I cap. So this is the direction of velocity given. This is velocity. This is how the charge is projected. And charge q is given, and this is velocity. What you need to find the instantaneous force F on the particle. Why instantaneous? As its position changes, field will change, and force also will change. How do you calculate force? So this is first part calculation is calculation of magnetic force on a moving charge particle placed in a magnetic field. What is that equal to? Q into V cross B. So, you know, moment I read this force, I know this is what I need to make use of. Here, charge is given, velocity is given. Only thing I need to figure out value of B. What is a B vector here? So can we calculate B vector at the origin? Yes, this is we have done field calculation. So field calculation we take as two semicircular arc and calculate the field. Can we all calculate B vector at the origin? Let's first calculate what is B at origin. So magnetic field at origin. How do we calculate its magnitude and direction? The semicircular arc for full circular arc, our field is equal to mu naught I by 2r. But this is half a circle. Magnitude due to each of the semicircular arc. Okay. So current I is going through each. So this also I, this is I. This is magnitude. Due to this arc which is lying in which plane? Is lying in vertical plane. Field will be in the horizontal direction. So again, if I write in thumb rule, due to this arc, field will be in this direction. One of the field is in this direction. Which direction I can write as? This is along minus I cap direction. How about a field due to the arc, which is like this? If I put my fingers along this direction of right hand, my thumb is pointing vertically upward. What is vertically upward direction in this particular is y direction. Next one will be equal to plus mu naught I by 4r. If this is, I have both the terms, can I find the cross product now? Now finding FB is easy. I can find FB. FB will be equal to 2 into B vector, also I'll put in vector form, B naught I cap cos of minus mu naught I by 4r I cap plus mu naught I by 4r B cap. And finding this cross product is pretty simple. We can easily calculate. There's no gravitational force. Okay, so this is one part of the question. And the second part is, if external magnetic field B naught J is applied, determine force F1 and F2 on two semicircles due to the field and net force on the loop. Now let's do the second part. Second part is force experienced by, first part was force on the charged particle moving in a magnetic field. Second part is there's a current element placed in a magnetic field, find force. That also IL cross B. So how do we find that? And also let's first mark which direction the field
Do we
is.
take a resultant length here?
Tell me. Yes, we can. Is the first thing what we need to check. Let's first mark what is the field here. Which direction the field is? B naught J cap. This is what the direction of field is. This is B naught J cap is the field. Is the field uniform or not? Is the field changing in the space? No, it does not depend on the coordinate. First, second part, what I notice, field is uniform. If field is uniform, I can replace them with resultant. Field is uniform. What I'll do, since the field is uniform, if I have to calculate field force on a current element which is not straight, suppose I have first part, I have to calculate on KLM, this part of element. I can replace with equivalent straight current. What is the equivalent straight one? It's simple. Why this is the first one, this is the element here. And if I have to write L vector for KLM, if I have to write what is the L vector here, L vector will be from K to M. What direction is that? That is minus K cap. Length is 2R and direction is minus K cap. That's L vector. So if I have to write force, either I can use right hand thumb rule or I can use the formula. Its current will be equal to I into L cross B vector. What is I here? I and L is equal to minus 2R K cap. And B vector is given as cross B cap. And how about force on the second? This is for the KLM. What about KNM part? For KNM part?
Resultant length will be same, right, sir?
Yes, resultant length in this case also same. This is starting point and this is end point. And the resultant length is same, direction is same. What will happen? The force also will be same. Second one also will have the same force. What is the resultant force? Sum of those two. Price of that. Why the force is net force is not zero? Because this is not a loop here. You understand, some of you may think it's a loop. Actually, it's not a loop. Current is entering from one side and this is not flowing in a circular loop here. That's when the net force is not zero. Same force, so we can calculate net force will be twice the force of this, which is both are in the same direction, same magnitude. Twice this force is the net force acting on the loop. Actually, the word here is of loop, but current is not forming a loop here. We notice here. So for some of you may think, oh, it's a loop here, net force will be zero. Loop is not a correct word, but yes, it is physically it is forming a loop. Current is not flowing in form of a loop. It's not the current start from here and set the same point. So what you notice here, it's not a current loop. Anybody has any query on this so far? Yes, is this clear?
Sir.
Gayatri,
Yes, sir.
is it clear?
Yes, sir.
You could have done on your own without any difficulty.
Yeah, I mean, I could do the first part, the second part I had confusion, but now it's clear.
No, but are you clear? Second part also, is it clear now?
Yes, sir.
Okay. this question, let's say this one is a even easier question. So all of you, please, first thing we need to focus on what we need to calculate here. Acting on a loop. Do we know the formula? What is for torque acting on a loop equal to? Torque is equal to
M
cross B. Okay. So if options are only related to magnitude. If only magnitude is required to found, this becomes even more simple. It becomes equal to mb into sine theta. In this case, how is this magnetic field is lying in the plane of the loop? This is a simpler case when magnetic field lies in the plane of the loop. What is the angle between the magnetic field and the dipole moment? We mark the direction of m vector here. What is the direction of m vector here? Now, can you tell me direction of m vector? It's a loop. Fingers curling along the direction loop, m vector will be perpendicular to plane of the loop. Since the loop is placed in xy plane, m vector will be perpendicular. Now, can we tell me the direction of m vector here? When field is in the plane of the loop. What will be the value of theta? Theta will always be 90 degrees. So this is equal to magnitude is equal to m into b. But if I have to do in vector form, then if I have to find m vector, what is m vector here? M vector, if I curl my fingers along the direction of current flow, which direction will my thumb point? What is direction of thumb?
Into the plane.
Into the plane, minus k cap. So I can write as, so m vector will be in minus k cap direction. Direction is minus k cap. And what is m value magnitude? I into r square. That will be magnetic moment. And what is I equal to? I equal gives 1. So it will be r square. It will be minus 4 by pi k cap. Are you clear?
Yes.
So can we also tell what is, can we write b vector in unit vector form? It is making 45 degree. So it will be b by root 2 and b by root 2. So I could have written as 1 by root 2 I cap plus 1 by root 2 j cap. If at all I need to find the answer in these directions, what would now what would the torque come to now? Can we write the torque expression now? It's m cross b. Which order? M comes first and b comes next. What is m here equal to? M is equal to minus 4 by pi
Minus
k cap cos 1 by root 2 I cap plus 1 by root 2. Is this something you can easily solve?
Yes, sir.
And if you have to find magnitude, it becomes much simpler. Directly, if you have to just find magnitude of torque, magnitude of torque is simple. Magnitude of torque will be equal to into simply m into b, because theta is 90 degree. This is something we should immediately spot. Whenever field is in the plane of the loop, theta is equal to 90 degree. It will experience the torque into m into b. So in that case, directly I could have calculated m is equal to what? M is equal to 4 by pi magnitude and b is equal to 1. That's the torque. But which direction the ring will rotate? If I have to figure out which direction the ring will rotate.
Sir,
Yes.
sir, isn't m equals to I into pi r square?
Yes, sir.
Sorry, I missed pi term.
Yes, sir.
Pi term I missed. My mistake. Okay, pi term I missed. Yeah? Okay. And how would this rotate? Can you sum up again without doing this calculation? Suppose I put it in 3 dimension. How would this tend to rotate? Which axis will rotate about if it is kept in free space?
Y is equals to minus x.
Can you think of which way it will rotate? And how, which axis it will rotate about? Can you visualize how it will rotate? So if I have to draw in 3 dimension, this is x, y, z. And this loop is placed like this. So to understand rotation, I can mark the direction of m vector and b vector. This b vector is like this. So which side the b vector is? B vector is like this. Where is m vector? M vector is along which direction? Minus k cap direction.
Oh, yeah.
So this vector has to rotate and tend to align itself. Which plane it will rotate about? This is slightly more complex. This is something how it should rotate so that it comes in the same. So it will try to what will M? This is B vector which is lying, and this is M vector. This M vector will rotate in such a way that it will come and align with this direction. What is the angle between the two? So some of you can visualize how it will rotate. It will rotate about the axis perpendicular to this. It will rotate about this axis.
Yes, sir.
Yes.
Okay. Next question. And this question also I'll give you all of you. Yeah. Okay. Let's start. The first thing what we'll do. Let's see how do we do step by step. Whenever field is given which has component in both direction, what we can do, we can split into two parts. So what I have done, I can take superposition. I can take the effect of x component separately and z component separately. So I have indicated as two different field. One is acting along, one is 3b0 acting along x-axis. That is 4b0 acting along z-axis. So I split into two parts. Okay, first thing. Second thing also, it makes it a little simpler in my mind. Second thing, what I understand here, the key part here is nuke is released. And it's like what does this hinge mean? See, the way our doors are hinged about vertical axis, similar way it is hinged about this axis, it can rotate in this particular plane. Now let's see what would have happened had a magnetic field not been there. If magnetic field was not there, this weight will act about center mass. And this weight will make it go downwards. It will rotate about PQ axis and keep vertical down, and it will become then torque will become zero like this. It will tend to rotate in this direction. So if I look from here, what will be the direction of rotation? If I see from here, the torque acting will be like this. Torque acting will be along y-axis. It will weight will tend to rotate. So what has to happen? Weight is acting downwards. What is now it is really found to remain in a horizontal position. It means some force must be acting in the upward direction. First thing what I notice here, step by step, let me write. First step I had done, I have split the field into two parts. Split the field into two components. Into its components. That's something it makes it a little simpler rather than looking at a complex form into two components. That thing what I'm concentrating on, I'm concentrating on the condition of equilibrium. And this equilibrium is not normal equilibrium. It is what kind of equilibrium? It's a rotational equilibrium, which makes question a little more complicated. What I understand from here, if FB was absent, there was no magnetic field and no magnetic force. What would have happened? It would have, because of weight, this whole thing will move downwards. It would have rotated about, so weight acting downwards, and it creates a torque. And it will make it rotate about PQ axis. And this is how it will rotate. So it means if it is in equilibrium, it means there must be some which force? Vertically upward force also. Now, which of the two fields? There are two fields here. This is red color field, this is blue color field. Which of the two field can create a force in the vertically upward direction? There has to be some force acting in vertically upward direction. That's my thinking now. Now I look at which of the two field. This force is, this field is vertically upward direction, or it will create force in the horizontal plane. It cannot create vertically, it cannot create a force which is in the vertical direction. Which field will create force in the vertical direction? The blue color. So only I component of field can create vertical force. So which direction the current has to be? So vertical force, it means when the field is like this, depending on the current, as this particular element, The force can be due to this field. Force could be up or force could be down. For equilibrium, which direction the force has to be? For equilibrium, the force has to be in upward direction. Question is, which direction should the current flow so that force is in the upward direction? B is this direction. I want force in this direction. Should the current flow from R to S or should it flow from S to R? Let me check the direction of
R to S.
R to
R
S.
to S. So direction of current we have. So we have figured out 1 by N. So 1 will Samjan. So current, since for equilibrium, force must be up. So for force in SR to be up, direction of current from R to S. So I figured out the direction of current now. What I do now, okay, I rub this off. So I figured out, so after all the discussion, only thing I figured out is what must be the direction of current. Let me mark that part also. So I've done something. This is the direction with the current will flow. So this is the current direction, this is the current direction, this is the current direction, this is the direction which the current is flowing. So I figured out direction. What is the direction of current in PQ? So if this is SR, this is direction of current. What is direction of current in PQ? From P to Q. Okay. Now this part I had done now. So now let's address the next part. What is the magnetic force in arm RS? Force in arm RS. How do I find force in arm RS? What condition I'll use to find the force in arm RS? What are the forces will act in RS? It will have field. Due to this field, force is acting in the vertically upward direction. Due to blue color. Due to red color field, which direction? The current is in this direction, field is up. Which direction the field force will act due to red color field, red color or Z component? Which direction will the force act? In RS, due to vertical component. So L is this direction, L is towards left, and B is upwards. This is first vector. So my first vector, L vector, is here for finding force in RS. This is my L vector, and B vector is up. So how would direction of force be?
Minus I cap.
Minus I cap. So I can mark the direction of force. So direction of force due to red color, this will be the direction of force. So due to blue color up, due to red color, and due to red color, if RS is inwards, every other thing also, what is red color indicate? Red color indicate force due to Z component of field. That's how the forces will act. What is the force in RS? It has two components, due to 3B0 and due to 4B0. When we calculate force in RS, how do we calculate force in RS? Force in RS will be such. So this is okay. So this is upwards. How will be the force in RP due to red, blue color? Will there be any vertical component in SP? Will there be any vertical component of force in SP? And this field, both are in the same direction. So blue color component, no force in SP. Blue color component, no force in SR. So RS, both the components will act, vertical as well as horizontal. PQ also, both the components will act, but other two sides only horizontal forces will act. That's how the forces are acting. How do I find this force now? I will again equate the torque about PQ axis to be 0. Force in RS, method of calculation of force RS is by equating torque to 0. Are you following so far?
Sir?
Yes.
So the red color force on arm RS won't create any torque?
Okay. Red color force, yes. The force is, what is the perpendicular distance of this force from PQ axis? Is this force passing through PQ axis or not?
Yes, sir.
That's why it will not create a torque. Are you following why it is not creating torque?
Yes, sir.
Only the perpendicular distance. Okay, so this won't create torque and this way any will cancel out. So when we calculate force on RQ, by torque about PQ axis is 0. I equate torque using equilibrium condition and torque about PQ to be 0. When torque will be 0, the two torques are acting due to weight. Weight will be mg and its perpendicular distance is a by 2. This has to be in terms of magnitude. This vertical component force, blue color force. What is blue color force? If current is I, force is equal to I into length B into magnetic field. Which component? Vertical component is only due to 3B naught into 3B naught. This is the force which is acting, the blue color force, and what is the perpendicular distance into A.
A, sir.
That's how I find the value of current. And thus we find the force. Actually, if I have to calculate force, if I had to just calculate force will be half of the weight. Why force will be half of the weight? It is acting at twice the distance or being equal. Other way I could have written it is equal to F is equal to vertical component of force into A. What is vertical component of force will come to? Vertical component of force will come equal to mg by 2.
mg by 2.
Okay. What will be mg by 2? And this is, if you found vertical component, can we find out horizontal component of force now? Whatever force acts, vertical component, horizontal component will be 4 by 3 times. What is resultant force acting in SR? Vector sum of the two. Okay, so this question, and if you notice this question, it is come in IDGE, it has come in advance, so it is not an easy question. But as if those who want to understand rotation motion and understand how this object rotates, it's a very good question to understand the basic concepts involved. And some of you may not, entire thing may not register in first instance. Try and solve on your own, you'll get an understanding. I think I have explained in fair detail about bit by bit how do we go about solving it. So I hope some of you have understood.
Yes, sir.
So okay, and how many of you think you would be able to solve this question on your own if you have to do in the evening? How many of you can, now without looking at what I have done on the screen, how many of you think can solve this question on your own in the evening today? Can you raise your hand, those who can solve? At least that is how many you feel that you understood? How many do you think you can solve each bit? It's not a simple question. Not a very simple question. And it has, there's something I hope all steps you have understood. Unless we do step by step, we pay attention to each detail, we'll not be able to get it right. This is not a simple question. And those who are interested, you can redo it. But this is a difficult level question, and definitely more than mains level. Typical question what we expect in mains, but you can solve it. Okay. Find the expression for I in terms of current. So yeah, this expression will get the value of current in other terms. That's how it will come. Okay. Good. I think some of you, those who are understood. Yes, Ahlad, you have some question now.
So if we take the torque about RS, we'll get mg times A by 2, right?
In that case, there's some reaction force acting in the hinge. Yeah, everything what I do, Ahlad, you miss out some point. There's some reaction, the force acting at this reaction also. The torque will be zero, whichever point you calculate to. When I equate torque about this axis to be zero, it will help me find the value of reaction here. This point also will have some reaction here. It will have some vertical component as well here. Understood?
Yes, sir.
It also will have vertical component. How much vertical component? This normal reaction will be actually equal to mg. What is the reaction hinge vertical component of hinge reaction? Vertical component of hinge reaction will be equal to mg. Why it is mg? Can figure it out. Okay. Let's look at this question. These are a little more difficult questions, but this one is not so difficult. So all of you try and think how to find torque on the loop. So first one, okay, I hope all are clear. We form 3 different loops. This is one the top loop, the side loop, and I'm not marking here, so equal and opposite current here along this side. Side loop, top loop, bottom loop. What we have to notice here, this is the direction of current in the top loop and bottom loop are opposite to each other. Since the direction of current flow is opposite, the area and current is same, both will. Okay. So let's one by one, let's do this one. The top one, what is by right hand thumb rule? Direction of M vector will be vertically upwards. In the side loop here, this is flowing like this. If I curl my fingers in this fashion, my thumb will point towards right direction. This is the direction of a second magnetic dipole vector. And third dipole vector, will it be upwards or downwards?
Downwards.
Downwards. When we take vector sum of this is all three have equal magnitude. Since they are in opposite direction, they will cancel out. So what is the resultant dipole moment here?
In the
The
direction
question was
of
only find magnetic moment. So it will be equal to current into area, and direction will be along j cap. So that will be I into L square into j cap. That's a dipole moment. And if since I have to find torque here, magnitude of torque is equal to mb sine theta, or I can find the cross product. What is theta here? This is b vector. This is m vector and b vector are in the same direction. Since the theta is equal to 0, torque will become 0. Suppose I change this question, I change the second part. If I write b is given as 3 I cap plus 4 j cap. In that case, what will be the torque? In that case, depending on how the b is given, now we can calculate torque. We take the cross product. Torque will be equal to
minus 3 k cap.
j cap cross 3 I cap plus 4 j cap. What I notice anyway, still the y component is not getting in. Torque is created only by the I component. So j cross I is equal to what? What does this indicate? How would this loop tend to rotate if you apply this kind of field here? How will this loop tend to rotate? Along which axis? Minus k cap. What does minus k cap indicate? How would it tend to rotate? If I have to, this is if I draw on minus k axis, about center mass, it will tend to rotate in this fashion. The whole thing, if I, yes, about center mass, it rotate in this sense. Okay, so I think more or less we have come to the end of session today. I hope all of you follow